Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video I want to talk about how we can find the sum of a finite geometric series. So we're going to jump right into it. We see our formula on the screen here in black. It says S of n, or the sum of the series, is equal to the first term, a sub 1, times 1 minus the common ratio, or 1 minus r to the n being the number of terms in our sequence, and then divided by 1 minus r. So we're going to jump right in. We have two examples. The first one is our rule is 1/2 times 5 to the power of k. We're saying k is equal to 1. That's our lower limit, so we're starting with the first term. And then our upper limit here is 6, so there are 6 terms in our sequence. So we're going to start off, and I'm going to write our equation S of n, or S sub n, is equal to, now let's write our first term. Well, notice here that our exponent is just k. It's not k minus 1. So those of you that are familiar with geometric sequences, when we have k minus 1, then the number that we see right there, 1/2, that would be our first term. But in this case, we don't have k minus 1 as our exponent, so let's just plug in 1 for k, because that would represent the first term in the sequence, and then let's just evaluate. So if I plug 1 in for k, we're going to get 5 to the first power. 5 to the first power is 5, and 5 times 1/2 would just be 5 over 2. So let's write 5 over 2 here. Now in parentheses, we're going to do 1 minus r to the n. So we have 1 minus, r is our number that's in parentheses here, so 1 minus 5. And then n would be the number of terms in our sequence, which would be 6. Okay, so now let's divide that by 1 minus r, which would be 1 minus 5. All right, so now we can leave our 5 over 2 here, and now let's simplify what we have in parentheses. Well, we know 1 minus 5 is going to be negative 4, and in our calculator we can do 5 to the 6th power, 1 minus 5 to the 6th, and that's going to give me negative 15,624. So now let's just divide that by negative 4, and now that's going to tell me that S sub n is equal to 5 over 2 times 3,906. Now I'm going to multiply this by 5 over 2, and that'll give us the sum of our sequence, or the sum of our series. So times 5 divided by 2, and we're going to get the sum as 9,765. Okay? All right, so that'd be the sum of our series for number 1. Okay, number 2, it is set up a little bit differently. Now notice we do have I minus 1 here. So what that tells me is now 6 is actually my first term of my sequence. So now we're going to write S sub n is equal to 6, and now in parentheses we have 1 minus. Well, remember our r value is there in parentheses, so that's negative 2. And the number of terms in this sequence would be 12, so we're going to raise that negative 2 to the 12th power. And then down here we have 1 minus negative 2. All right, so let's simplify again. So we're going to do 1 minus, and then we have negative 2 to the 12th power. So that gives me negative 4,095. And then we're going to divide that, and we have 1 minus negative 2, which would be 1 plus 2, so that gives me a 3. So I'm going to divide negative 4,095 by 3. So that's going to give me negative 1,365. And now let's multiply that by 6, and we get our sum for our series, which would be negative 8,190. Okay, so just to recap, I'll scroll back up to see our formula. That is the formula that we can use to find the sum of a finite geometric series.